Alright, so at this point you should be familiar with all of the parent functions. If I give you a quadratic, do you know what the basic shape of the graph is? Absolute value, cubic, square root, rational, all of those. You should be familiar with what those parent functions look like. And now we're going to talk about transformations. This is sliding them left, right, up, down, stretching them, shrinking them, and reflecting them. So those are the three main types of transformations. Sliding or shifting, so this is where we will take a graph and not change its shape or anything like that. You're just simply sliding it up, down, left, right. Reflection, either we'll be reflecting, flipping it over the x-axis or flipping it over the y-axis, and then a stretch or a shrink, causing the graph to move closer to the y-axis or closer to the x-axis. So what do those things look like, and how do I know if I have them? So we're going to talk about the three different main different types of transformations. So first, just shifts or slides. And each one of these will have a vertical component and a horizontal component, and you'll know which one you have by where it's placed. So shifts and slides come from just adding and subtracting values. So if you have something added or subtracted in your function, then you know that that is going to slide your graph either up, down, left, or right. So if something is done on the outside of the parent function, so what I mean by that, let's say I have f of x equals x squared, there's my parent function, and then I'm just going to throw on a little plus 2 on the end. That 2 is outside my parent function. Outside will always mean something vertical happened. It slid up or down, so vertically, it shrank or stretched vertically, or it reflected vertically. Anything that happens outside will be vertical. Since this is outside the parent function and it's either being added or subtracted, I know this is going to shift it up or down. Vertical will always be straightforward. I added 2, so the assumption is that I'm going up, and this is definitely the case. So with vertical, if you add, then you are going up. That's an arrow. Pretend that's an arrow. And if you subtract, you are going down. So the parent function is a quadratic that's centered at the origin. Since this is going up 2, I'm no longer at the origin, I am up 2. It's not any skinnier, any wider, it's not reflected, it's just simply shifted up 2. Now if I had x squared minus 2 right here, then I would have just gone down 2 instead of up 2. So again, knowing what those parent functions are is vital for you to be able to do these transformations. Alright, so if it's outside, it's vertical. Addition or subtraction means a shift up or down. Now if it's inside, this is going to indicate that you have a horizontal transformation. Again, the addition or subtraction will tell you that it's a shift or a slide. So what does that look like for it to be inside a parent function? So let's say f of x is, let's do the square root of x minus 3. Notice here that the minus 3 is inside the radical. So the parent function here is the square root of x. That minus 3 is not on the outside of the radical, it's on the inside of the radical. So this is inside my parent function, which tells me that it's horizontal. Now horizontal is always going to be opposite of what you, opposite of what you think it should be. So vertical is straightforward. If I had a minus 2, I would know I was going down. Horizontal is the opposite of what you think it should be. So the minus 3, you might think, it's horizontal, so I'm going to go to the left 3, but that is not true. You are going to go to the right 3. So horizontal trips you up and gives you the opposite. So with horizontal, again, if we're adding or subtracting, and we have these shifts, if you're adding, you actually go to the left, and if you're subtracting, you will go to the right. So keeping in mind what the parent function, the square root of x, looks like, It's centered at the origin and ever so slightly increases off to the right-hand side in that first quadrant. We're just simply going to shift it to the right 3. So instead of starting at the origin, I'm going to be 1, 2, 3 at positive 3 on the x-axis. There's my starting point, and boop, there we go. There's my transformed function. So these are our shifts and slides. They come where I'm adding or subtracting values, either outside the parent function, giving me a vertical shift, or inside the parent function, giving me a horizontal shift. All right. So we can also have what we call stretches or shrinks. Stretches, I think that's how you spell that, don't judge. Or shrinks. So this is where your graph, usually probably in high school you said it got skinnier or it got wider. That's only helpful if it's a two-sided function, like we have the quadratic right here. If it got skinnier, well, I know what that looks like. It's just me, little beanpole right here. And if it got wider, then you know, I know what that looks like. But what does it mean for a square root, a single-sided function, to be skinnier or to be wider? I can't wrap my head around that terminology. So what we actually mean when we say it got skinnier or it got wider, it shrank or it stretched, let me put that back up there, sorry. We're talking about how much closer it moved to an axis. So this quadratic, even if we shift it off, it's shrinking like that. It's being pulled in closer to my y-axis. And it's stretching, becoming wider. You can see it's flattening out towards the x-axis. So that's how we're going to describe these stretches and shrinks, by what axis it becomes closer to. So again, we will have vertical and we will have horizontal, and it works the same exact way as it did with the shift or the stretch. If it's on the outside of the parent function, we know it's vertical. If it's on the inside of the parent function, then we know it affects us horizontally. All right, so let's say, okay. With shifts and slides, that was addition or subtraction, if it was just being added or subtracted inside or outside my parent function. Stretches and shrinks come from multiplication or division. Division really is just multiplication, right? If I have x over 3, I can rewrite that as 1/3 x, right? So we're just going to stick with the multiplication route. If you see anything with division, you can just rewrite it as the multiplication. It makes it easier that way. Now, writing it as such, my value that I'm multiplying by will either be greater than 1 or it'll be in between 0 and 1. Negatives, we're just going to disregard for a minute. The negatives cause a reflection. So when we talk about multiplication for stretches and shrinks, if there is a negative, we will ignore it for the time being and know that means something else. All right, so let's say that I have g of x is equal to 2 square root of x. So the square root is my parent function, and I can see that this 2 is on the outside. Since it's on the outside, that makes it what type of transformation? Hopefully you said vertical. So since the 2 is on the outside, it gives me something vertical. It's either going to be a stretch or it's going to be a shrink. Which one? Well, vertical transformations, again, are very straightforward. So since that number is larger than 1, I'm multiplying by a bigger number, you would think it's going to get bigger, it's going to stretch, and that is exactly what happens. So if that number that you're multiplying by on the outside is larger than 1, so this value, we'll call it A for kicks and giggles, if that value is greater than 1, we end up with a vertical stretch. And what that means graphically is this graph will be pulled closer to the y-axis. Now, if that value that you're multiplying by is in between 0 and 1, then we have what we call a vertical shrink or compression / compression. either one. You'll see it called different things, shrink or compression. And again, what that means graphically is this gets pulled closer to the x-axis. So if it's greater than 1, 1.1, 2, 57, anything greater than 1, we have a vertical stretch, and it's being pulled closer to the y-axis. It's not shifted or reflected or anything like that. It just has, it just gets pulled closer to the y-axis. If it's in between 0 and 1, something like a third or 2/7, anything like that that's in between 0 and 1, then we will have a shrink or a compression, and that gets pulled down closer to the x-axis. So let's go ahead and graph this bad boy real quick. G of x equals 2 square root of x. So again, that parent function is the square root of x, so I know it should be centered at the origin. Centered at the origin and going off into the right quadrant. I'm going to go ahead and graph what that parent function looks like for a point of reference. It looks something like that. I'm going to call it the PF. That's my parent function. G of x here, we've determined that it has a vertical stretch, so it should be pulled closer to the y-axis. This does not shift it, it does not reflect it, or anything like that, so it still will start at the same exact spot at the origin. It's just pulled closer to the y-axis, and depending on how big that value is will determine how much closer it got pulled to the y-axis. I'm just winging it here so you can see it, and you'll be able to pretty much wing it on your homework as well. Alright, so what does it look like if I had a vertical shrink or a vertical compression? So let's say that f of x is 1/3 the square root of x. 1/3 is on the outside of my parent function, so since it's multiplied, I know this is a stretch or a shrink. It's on the outside, so it's vertical. It's in between 0 and 1, so I know it's a compression or a shrink, which means it is pulled closer to the x-axis. Again, there's no shift, there's no reflection, so it starts at the same spot. It's just down closer to the x-axis. We see the difference, so here is f of x. Alright, so what happens if that value is on the inside of my parent function? So something like g of x equals the square root of 2x. Notice now that 2 is on the inside. It is still being multiplied though, so I know it's a stretch or a shrink. But now since it's on the inside, it is horizontal. Remember, horizontal does the opposite of what we would think it would do. So with vertical, that 2, since it was greater than 1, gave me a stretch. With horizontal, the 2, since it's greater than 1, it gives me a horizontal compression. So if that value, we'll call it A again, it's fine. If that value is greater than 1, then we have a horizontal compression. And if it's between 0 and 1, we have a horizontal stretch. Now let's think about this real quick. A horizontal compression, so it's all about orientation, right? If I take this function and I compress it horizontally, I'm squishing it like this, right? Imagine you have Play-Doh in your hand or something and you squish it. What happens to it? It all squeezes out the top and the bottom, right? So horizontally, it shrank or was compressed, but vertically, it stretches. So a horizontal compression ends up more or less being the same thing as a vertical stretch. So this horizontal compression still pulls me closer to the y-axis, right? So if that value that it's being multiplied by is greater than 1, you know, regardless if it's a vertical stretch or a horizontal compression, right, just depending on where it's placed, you're still going to be pulled closer to the y-axis. Now, the vertical transformations tend to have more of an effect depending on the function, more of a pronounced effect than the horizontal will, but it'll still do the same thing. So the horizontal stretch, again, if you imagine having Play-Doh and you, nope, that's vertical. If you stretch it out like this, what happens to it vertically? It gets thinner in the middle, right? So a horizontal stretch is essentially the same thing as a vertical shrink or compression, so this pulls it down closer to the x-axis. Again, just not quite as pronounced as you'll see with the vertical. All right, so we have stretches, shrinks, shifts, and slides. The last thing we have real quick are reflections. Again, if it's inside, it's horizontal. If it's outside, it's vertical. And reflections come from just multiplying by a negative. Alright, so let's look at the difference here real quick. Let's say I have f of x equals negative absolute value of x. Notice, so the absolute value of x, you should recognize this as one of your parent functions. That negative is on the outside of the absolute value. Outside indicates vertical, so this gives us a vertical reflection. So if you think of reflecting something vertically, we're going up and down, right? So if I'm reflecting something top, bottom, up, down like that, what axis am I flipping over? I'm flipping over the x-axis. So a negative on the outside is going to reflect or flip your graph over the x-axis. So let's look at what that looks like real quick. So the square root of x, hopefully you're familiar, that makes the V shape. It looks kind of like a parabola, but it's a V, not a U. So this negative is just simply going to flip it on the other side of the x-axis. It's not stretching, it's not shrinking, it's not shifting up or down, anything like that, so it still starts at the origin, but now instead of being right side up, it just gets flipped upside down. So there's our vertical reflection. Alright, let's look at one more. G of x equals the square root of negative x. Notice here, my parent function is the square root of x, but there's a negative thrown in there with my x. So that negative is now on the inside, indicating horizontal. The negative, horizontal, writing is hard. Alright, so horizontal reflection. The negative's on the inside, so it is horizontal. It's being multiplied, so it is a reflection. So if you think about flipping something horizontally, we're going left to right, which makes us flip over the y-axis. So I chose the square root specifically for this, since I'm flipping over the y-axis. If I had chosen, to show you this, if I had chosen the absolute value function, just the parent function to reflect over the y-axis, if I reflect this over the y-axis, I'm going to end up with the same exact function. There's a special name for that that'll come up later in the semester. But the square root function is not one of those special functions. So if I reflect this, hopefully again you're familiar with what that parent function looks like. It starts at the origin and goes off slowly increasing in the first quadrant. This negative is going to reflect me back across the y-axis. So instead of being in the first quadrant, we will end up being in the second quadrant. Alright, so those are all of our transformations.